Uh, so after that of general method and functional function, which is chain rule, the next one we are going to talk about is first principle. So how are we going to make use of this first principle too as well? It's something simple, but you have to. It's somehow logical, so you just have to master the steps. But the first thing is this first principle is only for the theory text. If you are doing it objective, you don't need to waste your time using the first principle. So now this is just the notation of it. Dy dx is equal to f prime of x. You see this f prime of x is nothing but when we are looking for dy dx, limit of changing x to be 0 to del x to be 0 for the y del x equal to limit of changing x to be 0 for f of x plus changing x minus f of x divided by changing x. Let me explain this one in details. In this case, if I'm using first principle, whenever I see x, I will just be replacing x with x plus changing x, we call it delta x, you know. So now, so that's just the simple logic of that. If I'm solving a problem, instead of writing x, I'm replacing x with x plus dx. You can call it delta, or you can call it change. This symbol, call it delta. You can call it change. So I'll be calling it d so that to save my time. For example, let's say I want to find. Let's say they said differentiate. We said differentiate y is equal to 2x using first principle. So now, if I want to do that, if I use the common method that we firstly did, for the first one we did, the y ds of 2x, that's going to be 2, right? Yeah, good. So that means here too, what I need to do, that means if I apply the first principle to, I'm expecting to have my result to be 2. So look at the way I will do it. For the formula, y plus changing y is equal to x plus changing x. This was just trying to explain that if I see x, I will replace my x with x plus changing x. Even if it is plenty in that functions, whenever you see x, you'll be replacing your x with x plus changing x. So here, that means that we have y plus dy, y plus changing y is equal to 2. So instead of writing x, I will replace my x with x plus changing x. I hope you get it right. So now here we have y plus changing y, or y plus dy is equal to, if I open the bracket, 2 times x, we have 2x, 2 times x, we have 2 changing x. So the next step, I want to make my changing y at the subject, because if I have changing y over changing x, it's still the same thing as dy dx, right? Yeah, fine. So now, if I make this at the subject, if I collect the like terms, we have changing y is equal to 2x plus 2 changing x. So this is plus y. So when the plus y comes here, we are going to have minus y. So here I can have changing y is equal to 2x plus 2 changing x minus. So this is our y. From here we have that our y is equal to 2x. So I will replace, instead of writing y now, I will replace y with 2x. So here we have 2x. So here we have changing y is equal to 2x minus 2x. What are we going to have? Yeah, 0. So what do we have left? We have 2 changing x. So the next step is to divide all through by changing x. So divide through by changing x, divide through by changing x. So here, that means that we have changing y over changing x is equal to, so if changing x cancel changing x, what that we have left is 2. So assuming maybe after we divide all through by changing x, let's say we have another changing x left, then we are going to limit that changing x to be what? To be 0. I hope you are following, right? So even you can even use this approach. Anyone you use is still the same thing. Let's look at another problem. If they say differentiate, let me change this one. They said differentiate y is equal to x squared using first principle. I can still solve it the same way. That's y plus dy, x plus dx. So meaning here, you can see the x that we have here is x squared. So that means if I want to replace it here, of course, what I will have is y plus dy. Instead of writing rest, we are going to replace our x with our x plus changing x all square, because we have a square there. I hope you get it right. Even if you have a cube there, meaning you are going to have a cube here. Are you following? Yeah, good. So now, meaning this one means we should expand it 2 times. So here we have y plus change in y is equal to, now this means we should expand it 2 times. That is an x plus change in x, first one, x plus change in x. Okay, so assuming, let's say the power we have there is 3, so that means I have to write this one 3 times, and it's still going to be the same. So now let's expand this one. That means that we have y plus change in y, which is y plus y, x times x. We are going to have x squared, x multiplied by change in x, and we have x change in x. Change in x, we are expanding now. X times x. That's how we have x squared, x multiplied by change in x, and we have x change in x. So the second one now, change in x times x, and we still have x change in x. Change in x times change in x, of course, we are going to have change in x all squared. You just make a simple expansion. So here I can have y plus change in y is equal to x squared. So x change in x plus x change in x, we are going to have 2x change in x plus change in x all squared. I hope you are following, right? So now the next step, make your change in y as the what? Subject of the formula. So the moment I collect like terms, that way we have change in y is equal to x squared plus 2x change in x plus change in x all square. So this is plus y. When the plus y comes here, you are going to have minus y. I hope you are getting it right. Yeah. So from here we have that y is equal to x squared. So here if you have, that means that we have change in y is equal to x squared plus 2x change in x plus change in x all squared minus, so our y is x squared. So here we have x squared. So here we have change in y is equal to x squared minus x squared. What are we going to have? We are going to have 0. So what do we have left now? What we have left is 2x change in x plus change in x all squared. After that, I told you the next step is to divide all through by change in x. So if I do that, divide through by change in x, divide through by change in x, divide all through by change in x. So if I do that, or even if you want to use this, I will even teach you how to use this so that you see that it's still the same thing. So if I do that, so here, what we are going to have now is that if this cancel this, then we have 2x. So you can see this is change in x all square. This is 1 change in x. If 1 cancel 1 here, we are going to left to have 1 change in x. And I told you, maybe after you divide all through and you see that you still have 1 change in x, then you are going to limit the value to be what? 0. Go. So that means here, limit change in x to be 0. So if you limit to be 0, that means out here we have 2x plus 0. So of course, here we are going to have 2x. Let's say you only want to do this one direct. Let me teach you how to do this one direct. Let's say I want to do this one direct. Limit of changing x to 0 for f of x plus changing x minus f of x divided by changing x. The version we have is y is equal to x squared. That's what we have, right? You just say let f of x to be the problem given to you. Let f of x to be equal to x squared, right? So here, meaning I will replace with what? X plus d. So that means here I can say limit of changing x to be 0. So now here we have x plus changing x all squared. So my f of x is this minus x squared divided by changing x. Then you do it direct, just like the way we just finished solving it now. Changing x, limit of changing x to be 0. If I expand this, I think we have done it here. When we expand this, what we got is x squared plus 2x changing x plus changing x all squared minus x squared, and then all divided by changing x. So here we have limit of changing x to 0. So we have x squared. Now x squared minus x squared, that one can be 0, right? So if x squared minus x squared is 0, what we have left is 2x changing x plus changing x all square all divided by changing x, right? Fine. So the next step is you can divide through by changing x one after the other. If I do that, that means that we have limit of changing x to 0. For the first one, we have 2x changing x over changing x. Second one, we have changing x all square over changing x. So now this can cancel this, right? So if this are cancelled, that means that we have limit f prime of x You know, I told you f prime of x is nothing but dy dx. So now we have limit over changing x to 0. So you know, if changing x cancel changing x, what that we have left here is 2x plus, this is square, this is 1. If 1 cancel 2 here, that means that we have changing x left. So therefore, the next step is to limit the value of our changing x to 0. So that means here we have 2x plus 0, and here we are going to have nothing but 2x. Can you see that? Yeah, good. So now let's see another problem using the first principle. Maybe the question says using first principle to find, maybe it's come in form of fractions. Or okay, let's look at this one. Maybe they want to complicate the issue. Let's say we have to use y is equal to, let's say, 2x squared plus 5x plus 2 using first principle. You know, this one, if I use the normal method, I know the y dx of this is going to be 4x plus 5. So meaning if I apply the first principle, I'm expecting to have the same result. So let's do that to the formula. That is y plus dy. You know, I told you in that function, whenever you see your x, you replace your x with what? Yeah, fine. You replace your x with x plus the changing x. So here we have 2. So this is my x. It will become x plus changing x all square, because we have square there. Then plus 5. This is the other one too. And we have x plus changing x. You know, it depends. Even if you have them like 5 places, you'll be placing them. Then you can see this one doesn't have any x. Then plus 2. So here now, we are going to have y plus changing y. You know, we have expanded this one earlier. If you expand this one 2 times, all we have is x squared plus 2x changing x plus changing x all squared. Now, this one doesn't have any expansion. 5 times x, I have 5x. 5 times changing x, I have 5 changing x, then plus 2. What is going to be next step here? Yeah, is to open the what? Is to open the bracket. If I open the bracket of that, we have y plus changing y. 2 times x squared, we have 2x squared. 2 times this, and we have 4x changing x. 2 times this, and we have 2 changing x all squared. But here we have plus 5x plus 5 changing x, then plus 2. I hope you are getting it right. Now, good. So here, let's look at the one that are the same that we can just eliminate together. We can add them together. Let's see if you have anyone that we can add. Do we have anyone we can add together? Okay, no. So now, collect the like times now to make your dy, your changing y as the subject of the formula. So I can have changing y here, which is dy, is equal to 2x squared plus 4x changing x plus 2 changing x all squared plus 5x plus 5 changing x plus 2. So this is plus y. When the plus y comes here, of course, we are going to have minus y. And from here, we have our y to be this. I can replace that one. That's how we have changing y is equal to 2x squared plus 4x changing x plus 2 changing x all squared plus 5x plus 5 changing x plus 2 minus, so this is our y. Our y is nothing but 2x squared plus 5x then plus 2. You can see we just replace our y with the value we are given from the problem. So here I can have this one to be changing y is equal to 2x squared plus 4x dx. Yeah, you call it changing x plus 2 changing x all squared plus 5x plus 5 changing x plus 2. Now, if I open the bracket of this, minus times 2x squared, we have minus 2x squared. Minus times this, and we have minus 5x. Minus times plus 2, of course, we are going to have minus 2. So now, 2x squared minus 2x squared, you see, they will eliminate each other. Then, which one again? 5x minus 5x, we also cancelled. Then plus 2 minus 2, we also cancel. So meaning 2x squared can cancel 2x squared here. 5x can cancel 5x, then plus 2 can cancel minus 2. So what we have left now is change in y is equal to 4x change in x plus 2 change in x all squared plus 5 change in x. On to the next step is to divide all through by change in x. So if I do that, I will have divide through by change in x, change in x, change in x, and change in x. So now here, if this cancel this, what we have left is 4x plus, if this one to cancel this, I will have 1 left, 2 change in x. If this cancel this 2, I will have 5. We can see, after we do that, we can see that we still have 1 change in x. What are we going to do? Yeah, we limit the value of x to be, we limit the value of our change in x to be 0. If I do that, then here we have 4x plus 2 bracket of 0 plus 5. So here I will have 4x plus 5. I hope you get it right. So let's see another one. If it comes in form of fractions, you can have a problem that can come in form of fractions. So let's see that one. Okay. Let's see. Let's see if you have a question that comes in form of fractions. And now we're going to approach that. Maybe you say differentiate y is equal to 1 over x plus 2 using first principle. So how are we going to do that? If I follow the same process, I will still get to the same result. So this is y plus dy. As usual, it means whenever we see x, we are going to replace our x with what? X plus change in x. So here we have x plus change in x, then plus 2. 1 all over. Instead of writing this, we write x plus change in x. Then you can see here there's nothing we can do here. We collect the like terms. If you collect like terms, this is positive y. When it comes here, it's going to become negative y. So down here we have change in y is equal to 1 over x plus change in x plus 2. So this is plus y. So when it comes here, it's going to become minus y. So here we have change in y is equal to 1 over x plus change in x plus 2 minus our y is this. Our y is nothing but 1 over x plus 2. You get it right? So the next step is to find the XCM by combining these together. XCM, XCM here is going to be when we combine this together. So down here I can have change in y is equal to XCM of this. The first one is the second one. I have change x plus change in x plus 2. And the second one is x plus 2. So this will multiply this. This one will also multiply. That means we have 1 bracket of x plus 2. Then minus 1 bracket of x plus change in x plus 2. So what do we do? This, just like XCM, how many of these can we have in this? This will cancel. It will remain x plus 2. So that's why we have x plus 2 here. X plus 2 in this, it will x plus 2 will cancel x plus 2. We are going to left with our x plus change in x plus 2. Then with the one that we have here. So here I can have change in y is equal to, if I open the bracket of this one with 1, of course, we are still going to have x plus 2. So minus 1 times x, we are going to have minus x. Minus 1 times change in x, and we have minus change in x. Minus times plus 2, and we have minus 2, all divided by. So here, I can just open the bracket to make my work easier and faster. X times x, I can have this one to be x squared. X times 2, we are going to have 2x. Change in x times 2, I'm using this one. I will use this one to open the 2. This one to open the 2 at the same time, the third one too as well. So x times x, I have x squared. X times change in x times 2, I have 2x. Now change in x times x, and we have x change in x. Change in x times 2, and we have 2 change in x. Then the last one, 2 times x, we are going to have 2x. 2 times 2, we are going to have 4. I hope you get it right. Now fine. We just open the bracket of this one. So let's check the one we have at numerator if any value can cancel each other. X minus x, that's 0. Plus 2 minus 2, that's also 0. So what do we have left now? what we have left is now minus change in x, all divided by, we have x squared plus 2x plus 2x. I think that one can give us a 4x, then plus 4 plus x change in x plus 2 change in x. I hope you are getting it right. So what is going to be the next step? The next step now is just to divide all through by change in x. This is fraction, that's why we include that one. So since we have fractions, recall if you have fractions, this can change to what? Multiplication, because we are trying to divide all through by changing x. So meaning the changing x we are going to divide, it can only affect the one we have at numerator, not the one we have at denominator. So here we can have changing y over changing x is equal to minus changing x all over x squared plus 4x plus 4 plus x changing x plus 2 changing x multiplied by 1 over changing x. You get that? So here I can have this one can cancel this. If it cancels, that means that we have changing y and changing x is equal to, now what we have left now here is 1, right? So all divided by x squared plus 4x plus 4 plus x changing x plus 2 changing x. What will be the next step? Good, is to limit our changing x to be 0. So if I limit the value of our changing x to be 0, so limit the value of changing x to be 0 now. So that means here we have minus 1 all divided by x squared plus 4x plus 4. So if I'm limiting to be 0, this one will become x bracket of 0, then 2 bracket of 0. So there, after that, let me just write it here. I can have the y dx of this is equal to, now I will have minus 1 all over, the moment we put this one, x times 0 is going to be 0, 2 times 0 is going to be 0. So what we have left now is x squared plus 4x, then plus 4. So you can just, this is nothing but changing y over changing x to the dy dx minus 1 over, I can just write this one as x plus 2 all square. If I expand this, I will get this. I hope you are following me, right? So let's see another one that will come in form of root. When we have problems in form of root, if we have questions that comes in form of root, let's say they say y is equal to root of x, and we have to find this one using the first principle. I will still follow the same process. So now if I use this one, what I have here is the y dx is equal to limit of changing x to 0 for f of x plus changing x minus f of x over changing x. So meaning, I told you the function you will let it to be f of x. So here I can say let f of x to be the problem we are given, root of x, right? So then if I want to write f of x plus changing x, how are we going to write that? Can you guess how we are going to write that? Yeah, good. So meaning we just replace x as x plus changing x. Exactly. So then if I go back here now, what I will do is, if I see f of x is going to be this value, if I see this one is going to be this, right? So now if I plot the value, and we have the y dx of this one is equal to limit of changing x to 0. So instead of writing this, I will replace with that one, that is root over x plus changing x minus f of x is root of x all divided by changing x. So in this one, we call it a rationalization of sort. Since we have, if you are rationalizing sort, if I have something like this, let's say we have something like root of 2 plus 1. If I want to rationalize it, if what we have there is positive, if I want to rationalize it, it's going to become negative. Root of 2 minus 1, root of 2 minus 1. I hope you get that all right. So now I want to rationalize this one. You can see what we have between them is negative. So if I'm rationalizing them, it's going to be positive. So that means here, this will now become multiplied by, this is the one that have the root. So we have root of x plus change in x plus root of x all over root of x plus change in x plus root of x. You understand that? We are just trying to rationalize this value. So what we have is minus. So that means if I want to rationalize it now, it's going to be positive. So meaning numerator for numerator, at the same time denominator for denominator. So here I can have dy dx is equal to limit of changing x to 0. Now I want to make a simple expansion. Recall that under the information of our previous video, we discussed that if you have two numbers that are the same and you're checking their roots, you can just pick one out. Let's say I have a number like root of 2 multiplied by root of 2. You see, since the number we have in the root are the same, if I have root of 2 times root of 2, this is nothing but 2, right? So now if I have root of x plus change in x multiplied by root of x plus change in x, what are we going to have? Yeah, we're going to have x plus change in x. Now the second one, root over x plus change in x and root of x. Definitely, I will just have plus x bracket over x plus change in x, right? So now minus root of x times this one too as well. We have minus bracket x plus change in x. Then the last one, minus times plus, and we have minus root of x multiplied by root of x is going to give us what? Yeah, fine. It's going to give us an x, all divided by, now we don't need to expand this now to waste your time, change in x over x plus change in x, then plus root of x. I hope you get that. No, fine. So now, so here we can have this one to be change in y over change in x is equal to limit change in x to 0. Now, if you look at this, x minus x, what are we going to have? We have 0. So plus root of x plus change in x minus root of x plus change in x. What are we going to have also? That's 0. So meaning x can cancel x here, but at the same time, this cancel this. So what we have left now is change in x divided by change in x bracket over root of x plus change in x plus root of x. So now we can see this and this can cancel because they are the same. If this cancel this, so that means that we have dy dx is equal to limit of change in x to 0, 1 over. So what we have here now is root of x plus change in x plus root of x. So the next step is to limit our change in x to what? To 0. So if I limit that one, that means that we have dy dx is equal to 1 over. So I'm limiting my change in x to 0 now. So we have x plus 0 plus root of x. So here we can have this one to be 1 over, x plus 0, we are going to have x. So then here we have root x plus root x. So here we are going to have dy dx is equal to 1 over root of x plus root of x. Of course, we are going to have 2 root of x. So that's all about for the first principle. So just know one thing. Under the first principle, when you have x, you'll be changing your x to be x plus changing x, depending on the variable that we have. And after dividing all through by changing x, then you limit the value to be what? To be 0. So that's all about what we have for the first principle. So the next one we have is product rule.